5.5, solving inequalities using multiplication or division. Now, we solved equations using multiplication or division, and we were allowed to multiply both sides by a non-zero number and keep equality, or divide both sides by a non-zero number and keep equality. And it kind of works the same way for inequalities. You can multiply both sides by the same number and divide both sides by the same number, but one key difference. And I'm going to show you with a couple of examples here. Let's say I have this inequality. You will agree 5 is greater than negative 2. If I multiply both sides by negative 3, right here, negative 3 times 5 is negative 15. Negative 3 times negative 2 is positive 6. Do you see that it's not going to be a greater than anymore? Negative 15 is not greater than 6. This switches. The sign flips. We call it reversing the order. Okay? Look down here. Negative 10 is less than 20. Less than. Negative 10 less than 20. That makes sense. If I divide both sides by negative 2, negative 10 divided by negative 2 is positive 5. 20 divided by negative 2 is negative 10. You see, the less than doesn't work anymore. It becomes a greater than. Now, does that mean that anytime you multiply or divide, you have to reverse the order? You have to flip the sign around? No. It means only if you multiply both sides of an inequality or divide both sides of an inequality by a negative number. Notice that they are negative numbers. If you multiply by a positive or divide by a positive, you keep the same order. It doesn't change. Here's the property. Now, this is an abbreviated version. And the reason I only have multiplication here instead of multiplication and division is because the rule is pretty much the same. Given A, B, and C, C not equal to 0 as real numbers, if A is less than B and C is greater than 0, that means it's positive. If I multiply both sides by a positive number, it stays less than. You see how it's less than here? It's less than here. It keeps the same order. Dividing the same thing. If I divide both sides by a positive number, I keep the same order. On the other hand, and this is the one that's a little different, if A is less than B and C is less than 0, that means C is a negative number. Less than 0 means negative. If I multiply both sides by C, a negative number, it was a less than, it becomes a greater than. This is reversing the order. The same thing goes with division. If I divide both sides by a negative number, I have to reverse the order. I flip the sign around. Greater than becomes less than becomes greater than or equal to becomes less than or equal to, less than or equal to becomes greater than or equal to. Here's some examples. Solve and graph. Now, we're still graphing the solution sets on the number line. K over 8, K divided by 8, greater than or equal to negative 5. To solve for K, I've got to get rid of the 8 that's dividing into it. And we know the inverse of dividing is to multiply. So just like we did with the equations, I'm going to multiply both sides by 8. Now, because I'm multiplying by a positive number, I keep the same order. It started out as a greater than or equal to, it stays a greater than or equal to. And as you can see here, they cross cancel right out. I get 1K, or K is greater than or equal to 5, or 8 times negative 5 is negative 40. So if I want to graph this, I'm just going to put down the key value here because don't have a ton of space. K is greater than or equal to negative 40 means filled in dot at the negative 40 because of the equal to. Greater than means all the values to this side. Big arrow on the end. Next example. Negative 18y less than 72. To solve for y, I've got to get rid of the negative 18. That's times it. So just like I did with equations, something times, I do the inverse operation, I divide. So I'm going to divide both sides by negative 18. So I'll divide that side by negative 18. I divide this side by negative 18. Now, because I'm dividing by a negative, I reverse the order. The less than becomes a greater than. You can see why I don't just attach to the original problem, the divided by negative 18. Students have a tendency to do that because then the inequality sign doesn't change. These negative 18s are going to cross cancel right out there. I get y is greater than. Positive divided by negative is negative, and 72 divided by 18 is 4. So I get y is greater than 4. I draw my number line. I'll put my key value of 4 here. There's no equal to, so an open circle at the 4. And because I want greater than negative 4, I shade to the right. All right, the next example is another division, and that my variable is being divided by a number. It's being divided by negative 6. So I will multiply both sides by negative 6. Now, because I'm multiplying both sides by a negative, the greater than becomes a less than. You reverse the order. Everything cancels here nicely. I get 1n or n is less than negative 42. So I draw my number line here. I'll put my key value of negative 42. I want n less than negative 42, so that's an open circle, and I shade to the left because it's less than. Last but not least, on this screen here, I have 4x is greater than or equal to negative 28. The x is being divided or multiplied by 4, so I'm going to divide by 4. Now I'm dividing by a positive. Now yes, I know that's a negative, but I'm dividing by a positive, so the order stays the same. And as you can see on the left, the 4's are going to cancel as a factor of 1. I get 1x or x greater than or equal to negative divided by positive is negative. 28 divided by 4 is 7. X is greater than or equal to negative 7. I draw my number line out. I put my key value of negative 7. Because of the equal to, it's a filled in dot. And because it's greater than negative 7, I shade to the right, and I fill that all in. All right, so be very, very careful on this one. If you multiply or divide both sides of an inequality by a negative number, you must reverse the order. Two more just to make sure. T over negative 4 is less than or equal to negative 8. I'm just going to solve this one. I'm not going to bother graphing it. My variable is t. It's being divided by negative 4. That means I have to multiply by negative 4. Both sides by negative 4. Because I'm multiplying both sides by a negative, I reverse the order. It becomes a greater than or equal to. This cancels as a factor of 1. I get t is greater than or equal to a positive 32. Over here, my variable x is being multiplied by negative 7. I will divide by negative 7, both sides. Notice how I write it down without the inequality sign, because now I look, I'm dividing by a negative. I must reverse the order. Cancel as a factor of 1. I get x is greater than or equal to negative 2. Now this next one's a little different. It says, tell whether the given number is a solution. Now remember, it's a solution if it makes it true. So to see if it makes it true, I'm going to substitute it in. I get negative 24 over 8 is less than or equal to negative 3. Well, negative 24 over 8 is negative 3. Negative divided by positive is negative, and 8 goes in 3 times. Is negative 3 less than or equal to negative 3? And it is equal, so my answer is yes. Now this one is really different. It's a story problem here. It says, on average, a customer service representative helps at most 160 customers during an 8-hour workday. Write and solve an inequality. Find the average number of customers, C, she can help during each hour during one of her work days. Well, if she can get C done per hour and she works 8 hours, then 8C would be how many customers that she will help during that work day. Now it says here at most 160. Now even though the word most, most people think of more than, at most means that's the top. It can be smaller, but it can't be greater than 160. So it is less than or equal to 160. Now I can divide both sides by 8, and the order stays the same. C is less than or equal to, looks like 20. So it says here that she can help at most 20 customers per hour. She can help at most 20 customers per hour. Now remember, if you're solving inequalities, you can add or subtract anything to both sides and the order stays the same. But if you multiply, and that also works for multiplying and dividing by positives, the order stays the same. But if you multiply or divide by a negative, as a couple of examples up there show, you must reverse the order. And this will become easier as you practice, practice, practice.